Oh, really?
All right, here we go. Solving trig inequalities. We're back. Do y'all have your calculators at the ready? All right. Let's do this quick then. All right. I'm going to show you how to do this without a calculator, and I'm going to show you how to do this with a calculator. All right. So let's say this is a non-calculator question. All right. So if this is a non-calculator question, how would you solve it? Is 1/3 on the unit circle? Mamma mia, that's a spicy meatball. If this was, how would you solve this if it was non-calculator? Subtract the 1/3. And I get cosine of x is greater than or equal to negative 1/3. What do I do to both sides? Cosine inverse. So I get x is greater than cosine inverse of negative 1/3. Now wait a second though. Don't we usually get two of these? Oh, I don't know. I am.
Why are you doing a year left?
All right. Now think about this. Don't I need two answers for this though? With cosine, think about this. With cosine, what's true about this function? It is
Even.
It's even. So it means if positive is the solution, so is negative. Okay. Now I'm going to really knock your socks off. This is going to be insane. So you agree it's going to be from like, I want to know where it's greater than 0, right? Yar? So according to this graph, it'd be from here to here and here to here, right? But I don't know what those two numbers are. Oh, never mind. We're going to do the graph way. So you agree from here to here, it's from, yeah. So what's x got, what's this value going to be equal to? That's my negative cosine inverse of 1/3, right? I'll put negative 1/3, but could I have changed that to positive 1/3? Actually, you guys don't know that yet. I'm going to make it positive. Do you know why I can do that? Because it's even. Cosine of x is the same thing as cosine negative x, correct?
Yeah.
It's even. It's whoop, 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 same. Yeah, they're the same thing. They're symmetric. Yeah, I don't know why I made those sound effects. And you agree at this point is cosine inverse of 1/3. So I have the negative and the positive, right? So what's x have to be in between? I should just put equal up here, actually. I should just solve that and then use test pointing, kind of. I know, it's fun. So x has to be greater than or equal to negative cosine inverse of 1/3 and less than or equal to positive cosine inverse of 1/3. All right, so that would be a non-calculator answer. Because if you don't have a calculator, can you give me those decimals?
No.
Good. If you can, you probably don't need to be in this class. Let's say you were able to use a calculator. What would you do? I would graph that on my calculator. And I'd get that graph, you know what I mean? Look from 0 to 2. Oh, yeah, whatever. And I'd look from 0 to 2 pi. And I would do second calc intersect. It won't look just... I do second calc intersect, right? Y'all agree on that? Just like we just did. Because I graphed that. And I'm looking for where am I above? Where am I above that x-axis, right? So I would do 0, bracket, 2. What's that point? 1.91. Again, calculator did it for me. So I'm going to put that in a bracket. And then from, what's this point? If you guys need me to do this on a calculator, just ask. I did not get 3.82. I got 4.37. Now I got a question for you. Could I put a 2 pi there? Because when does it stop? At 2 pi? You can. That looks kind of goofy. If you want to, you could do 6.38, right? Again, calculator, second, calculate 0. Was I saying intersect? I guess you could if you plug in y equals 0. I would do a 0. You guys should see your faces. You guys look so happy. What a good day today is. All right, that was fun. Let's do another one. Let's do 3 more. Tell me why ain't nothing but... Oh, I'll get flagged. All right. Whatever. I like being behind in the count. All right, let's do this one. Ew, gross. All right, let's solve this equality. So let's do it without a calculator and with a calculator. Oh my gosh, this one's going to be wild. You guys want to see something wild? Let's think about the graph. What would 4 absolute value of tan of x minus 1, let's say it was equal to 0, and solve it. What's this graph look like if I didn't have a calculator? What's absolute value do? Makes anything positive, right? So if a normal tan looks like this, right? What would this side look like? It would go like that, right? Does that make sense? Because it's absolute value. What's that negative 1 going to do?
Down 1. No? Yes. What are you doing?
Why don't they have it shifted down one on there? Yeah, I'll shift that whole thing down 1, right? And then the 4 will just stretch it vertically. Sound good? I'm spacing right now. Oh, I see what happened. So think about this. Our graph is going to look something like this, right? Does that kind of make sense why it would look like that? No, they'll still be asymptotes, right? Because we flip the curvy part up. All right, I figured it out. Let's solve it like we didn't have a calculator. Let's solve this like I didn't have a calculator. Do you agree that'd be 4 tan of x equals 1? Tan of x equals 1/4, right? Now what do I do with that? What do I do with that absolute value? It's going to be positive or negative. So tan of x has to be in between 1/4 and negative 1/4, right? Which makes sense because over here, that's kind of what we're finding. So now what can I do to everything? That won't give me my actual right way though. What do I do to everything to get x by itself? Inverse tan. Gross. Does that actually work as an answer?
Yes.
No, because that's less than 0. But watch this. You want to make it work? Kinda. This is, again, if it's a non-calculator one. Could I add my pi k to it? Wait, not pi k. Oh, yep, pi k, because we didn't touch it. So again, if it's non-calculator, that would be your answer. That works. What if it's calculator? What would you do? Crap it. Plug this in your calculator and see what it looks like. See if we were right. Abs. Hit the math button. Abs. So those shaded parts are what we're looking for because that's where we're less than 0. Remember, we have to cut it off at pi, right? Because it told us to. We aren't including pi this time. So they're goofy. Tell me what your graph looks like. I'll look at my calculator. Wabbit, 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 wabbit.
Yep, you're right.
It's my first rodeo. If you guys want me to be honest, this right now, where is abs? What number is it?
Number. Get over number.
I wish it was that easy to get abs. Tan of x. All right. They're V's. Math, and then go over 1 to numerator. It's abs. Are you guys going to take my word for it when I hit second, calculate 0? All right. So I'm going to go 0 to... Wait. Not... Why can't I use a bracket that time? I should be able to. I'm going to put a bracket. Because am I less than 0 at that point? Does that point exist on my interval? So I'm going to leave it bracket. I'm going to disagree with it. Then what's this point right here? 0.245. Now this one's going to be parentheses because it's not or equal to. And what is it at that point? It is 0. And 0 is not less than 0. And that point I got as 2.9. 2.896, right? What's the number after 6? Does it round up? I wonder why they did. I'm just going to put... I think it depends on your calculator. Sometimes these might be slightly different. Now, why am I going to put prime parentheses when I put a bracket for 0? I'm just matching. Because I'm not 0 there, I am negative. Phew. All right. Let's add story prompts to this. Y'all, we got a month and 3 weeks left of pre-calc. A month and 2 weeks if you take out spring break.
How much more? Take every
Review. We have a month of new material.
But isn't that also included? Yeah.
We have 3.5 weeks of new material. I have it mapped out. Yep, 3.5 weeks of new stuff, guys. And this stuff, I'm not gonna lie to you, this is way different than pre-calc I talked before. This is definitely AP now. We've made it. All right, let's get wild. You know what? This next problem might make you guys feel a little bit more comfy, cozy. All right. When breathing, a normal cycle takes place every 5 seconds. Velocity of the airflow is measured after X seconds is multiplied by this, right? Because it would be negative velocity, positive velocity, velocity direction measures. Does that make sense? Air in, air out. So periodic function. Velocity, it just says it's positive when we inhale, negative when we exhale. So we increase our air pressure, then we decrease it. Make sense? So for one breathing cycle, when is your breathing greater than or equal to 0.3 for velocity? This would be a non-calculator one. Watch this though. Let's sketch a graph of it to help us see what's going on before I solve it. You don't have to sketch a graph, but I'm always going to sketch a graph myself so I can kind of visualize what's going on. All right. If I were to graph this, I'm going to make my life even... I'm going to do it differently than they did. I'm going to graph... This is the Mr. Twilliger method. Maybe it's wrong. But this is how I think about this. I would graph this, right? Is that something I can graph pretty quickly without a calculator, right? So let's see if we can remember it. What's my amplitude? 0.6. What's my period? 2 pi over... it tells me right here. What's my period? 5. Let's try this. Now, I could have done 2 pi divided by 2 pi over 5, right? You still get 5. What's that negative 3 going to do? Yeah, it's going to shift that to negative 0.3. Sorry, I don't put my... I am not a big... I don't put zeros in front of my decimals. I don't know why. I know it's not the common way to do it. I just never did it. All right, so when I graph sine, where do I start at? Right here, right? And then I'm going to go up, down. I hope my way works. I never tested it yet. Well, let's hope it does. I never tested it. I'm just trying it now. Do you guys think this way will work? We'll see. I don't think it does. All right, let's try it. Half of 5.
The max. Yeah.
Yeah, the max is 4. Oh, yeah. Oh, that's... Yeah, so we're going to find... Oh, okay. Hold on, guys. Give me a second. Why wouldn't this work? You'd have to find those 2 points based on my graph. But you're not going to be able to. But That's what I did. I'd be looking for that interval. Never mind. Don't use it that method. Don't do it that way. Don't do Reese. Don't do it that way.
So you're sure this is a non-calculator question?
1000%. Watch. Watch this. Watch me do it without a calculator. No. To do it this way, when I shift it down, I'm looking for where I'm greater than 0 because that's what my equation asks, right? When I set it up. So you have to find those 2 points. Now, what I'll say is this. I can't solve it this way, but I know what I'm looking for now. Does that make sense? I would have graphed it anyways. I was just trying to see if I could solve it, and I can't. Because the way I did it, then I'm looking for when is it greater than or equal to 0. So I'm looking for that interval. So that still works, right? That's my interval I'm going to be looking for. I'm okay. Now let's solve this beast. Let's do it the non-graphing way. Would I still graph this problem? 1000%. You still need to graph it so you know what you're looking for. Yeah, you don't want to graph it? All right, let's solve it then. What do I do to both sides first? Divide by 0.6, right? I'm not publishing this video for sure. What's 0.3 divided by 0.6? 1/2. Uh-oh. Is 1/2 something I can take sine inverse of?
Yes.
All right, let's do it then. I'm going to sine inverse both sides. So even though this problem didn't look like it was possible without a calculator, what is it? So if this is a non-calculator, you know that it's going to be on the unit circle, right? You know it has to be. So that's one nice thing. So I get 2 pi over 5x. Yeah. Is greater than or equal to, what's sine inverse of 1/2? Where's that pop up? At pi over 6. Wait a second, doesn't it happen twice? Where else does it happen? Y'all agree? If you want, you can label these x1, x2. Now, what do I do to both sides to get rid of those fractions? Multiply by the reciprocal. Oh, jeez, this is too much work. Yeah. What happens to my pies? So I get 5 over 12, right? Yeah. And then what happens to my pies? They cancel. So I get 25 over 12, right? Now this is where it gets, this is where it gets confuzzling. What the question is going to ask is, where are both of those true? Like, what's the overlap? What that gave me, actually, this is where it throws some people off. So I solved them both. They're both greater than or equal to, so why can't I just say that one? What happens at that second point we found? It flops, right? This is why I graph it. Do you know what I'm saying? I don't know which one, x1 or x2. Actually, I need to switch the signs. You have to graph it and look at it. 5/12 is before 25/12, correct? Yeah. What? No, because this would be 5/2, and that'd be 0. And half of, well, actually, yeah. So half of that's 5/4, right? Half of that is 5/8. It's half of a midpoint.
Yeah. Why could you just do that? not exactly.
No, because half of that's 5/8, and then you have to half it again to get. It doesn't actually work because that's a third the way in between. You have to do it that way. So what's my final answer on this? Where is it above 0 on this graph? And that was a lot of work to do this one problem.
I see this on the AP test.
No, at least do some work. They get it is points. It's points based, not rubric. So they'll give you some points if you. Oh my gosh, that's how long that problem took. You'll get some points for showing that you like make a sketch. That'll give you some points probably. Just do that. Don't write. I did have a student once say, right, this test is not reflective of my teacher. Like, don't do that. At least try.
No dice.
No dice. What does this mean?
So you mean if I write something down and make the person who's grading my test laugh about the extra points?
That was for real.
So, how can you say it? On the interval 5/12 to 25/12. Can you write intervals like this in your? You can. That's acceptable. We did that in AP Stats. We do that. You are inhaling at least that's filthy. At least 0.3 liters of air. Right? I stand by that.
Yeah.
All right, let's look at 15. Why not? No? Yeah, I will. Hey, what I think I'm going to do tomorrow, because these are taking a while, is I'll give you guys time to work on 310 in class, and I'll make that a video. Seem fair? Because I would like you guys to probably ask a lot of questions tomorrow. Make sense? So I'll make that a video. Yeah, I don't. Yeah. We got time. Actually, I'll make you a deal since I probably don't have time. How about this, though? If I give you 8 minutes right now, would you guys promise to try a few problems?
I can try.
And then tomorrow I can finish that. I can do the one example, take 5-10 minutes. So that way I'm not rushing it through it, because there's something I want to show you on this one. Give it a try. Give some problems a try.